Indices. Okay, there's a couple of rules that we need to remember for indices. I'll use pronumerals here. So if we've got x to the power of 6 and I want to multiply that by x to the power of 3, as long as these two are the same, I keep the base and I add the two little numbers. So it'll be 6 plus 3 is 9. So the answer to that is x to the 9. If I have x to the 6 divided by x to the 3, these two are the same, so I keep the x, and this time I subtract the numbers, so 6 minus 3, which is 3. If I want to raise x to the 6 to the power of 3, that's x to the 6 times x to the 6 times x to the 6. A shortcut is to have x to the, and I times those two together, so it's going to be x to the 18. Another rule is if I've got x to the 0, anything to the power 0 is always 1. They're the basic rules involving positive indices, but they do get a little bit harder. Let's have a look at the next ones. If I have 10x to the 6 and I want to times it by 5x cubed, I have to multiply the big numbers like I would normally do, so that becomes 50. And then, just like before, we have x to the 9. If I'm dividing and I have 10x to the 6 and I'm dividing by 5x cubed, this time I divide the big numbers, so 10 divided by 5 is 2, and then, like before, x to the 3. I also have to be careful if I've got 10x cubed and I square that, I have to square the big number, so 10 squared is 100, and then when I square x cubed, I get x to the 6th. With the power 0, if I've got 10x to the 0, we know that anything to the power of 0 is 1, so that's that bit, and I've got 10 lots of that. So this one is 10 lots of 1, which is 10, which is different if I've got 10 x's and I want to raise all of that to the power 0, because this is in a bracket, so it doesn't matter what's in there, anything to the power 0 is 1. Then we move on to negative indices. X to the power of minus 1, the minus means 1 over. So once I've used the minus, that's the 1 over, all I've got left is the x and the 1. So if I have x to the power of minus 5, the minus sign means 1 over, and then what's left over is the x to the 5. That changes if I've got a number in front. This is really 3 times x to the minus 5, so it's 3 times 1 on x to the 5, which is 3 over x to the 5. Something else that we have in indices is scientific notation. If I have something like 7.3 times 10 to the 5, if I want to write that as a normal number, the 7 and a 3 is still there. We'll need some zeros, don't know how many, but the decimal point was there. But because of the power of 5, I want to make it 5 times bigger, in powers of 10. So we go 1, 2, 3, 4, well, I need one more. So 7.3 times 10 to the power of 5 is 730,000. If I've got a number that is multiplied by 10 with a negative power, like negative 4, this time it's going to go the other way. I still need my 3 and my 7. The decimal was there, but the number is going to be smaller by a power of 10 to the 4. So if the decimal was there, then it's going to go 1, 2, 3, 4. So that's where my decimal is going to go, and I fill these with zeros. So the answer is 0.00037. If we're going the other way, and I've got a number like 123,000, to change it into scientific notation, it has to be a number between 1 and 10. So this one's going to be 1.23 times 10 to the power of something. Now, I want to put the decimal in there, but at the moment it is in there. So it is 1, 2, 3, 4, 5. So 10 to the power of 5. If I have a decimal, like this one, okay, same thing happens. I still want a number between 1 and 10. So this one will have to be 1.2 times by 10 to the power of something. I want the decimal to go in there. So that means it's going 1, 2, 3, 4, 5. But because it's a small number, it won't be 5, it will be -5 because the decimal is from the other direction. And that sums up what you need to know for indices.